In this video, we are going to solve this word problem. We're going to create a picture and just kind of see what kind of situation we have going on here. So it says we have a vertical 45-foot pole is placed on a hill that has inclined 17 degrees to the horizontal. Okay, so here it is. We're on a hill. It is set vertical. How long a wire is needed if the wire is placed 5 feet from the top of the pole and attached to the ground at a point 32 feet uphill from the base of the pole. So 32 feet, and we are attaching it at a height of 5 feet. So how long does that cable need to be? All right. So I'm going to draw my own picture on this, try to make some sense out of it. Oh, sorry, it's 5 feet from the top of the pole. So let's see. So we have this vertical pole. It is on a hill, and that hill is 17 degrees from horizontal. So that's there. And then we have this pole that's attached down like that. And we don't know what that is. And I doubt that that's a 90-degree angle, and those are definitely not 90-degree angles. So some pieces that we know. We know that this height right here is not 45. The pole is 45, but you're attached 5 feet from the top, which makes this 40. The hill is 17 degrees, but we are 32 feet uphill to where we're attaching the cable to the ground. And then if this is 17 degrees from horizontal, this is vertical, so that is 90 degrees total. So if we take 90 minus the 17, we're going to get 73 degrees. So this piece is 73 degrees. All right, so let me redraw. Let me kind of knock out some of the noise here. That's not very good. So there we go. Okay, so if that's 73 degrees, that's 40, and that's 32. And we don't have a right triangle. Our choices are law of sines or law of cosines. So since I start off wanting to use law of sines ends up not being an option because I have to have one full fraction. So I need to have the side and an angle across from each other, which I don't have, which means it has to be a law of cosines. And this is what we're trying to find. We're trying to find that length right there. So this is a law of cosines because we kind of have everything on one corner. So we are looking to use this formula that looks like this, where it's a squared equals b squared plus c squared minus 2 times bc times cosine of the angle in between. So those are two sides, and the angle in between is what that represents, which is exactly what you have, two sides and the angle in between. So to find this, that's our x value. And then the 40 and the 32 are our two sides. So 40 squared plus 32 squared. And then minus 2 times those exact same two numbers. So 40 times 32 times cosine of our angle in between, which is 73. Okay, so I'm going to throw all that into the calculator. Let's get ourselves some sort of a value, and then we'll finish solving it. So we'll put that all into the calculator. We're looking at 40 squared plus 32 squared minus 2 times 40 times 32 times cosine of 73. Cosine 73. All right, so that is some decimal. So it's 1875.52, blah, blah, blah. I don't want to round anything, so I'm just going to show that here's my value. And then we have to get rid of the square by square rooting. And so x is going to equal whatever the square root of that is. So we'll do the square root, which is right here. So second square root. And I want to do the square root of that value. And that 43.3 represents the length of my cable. So 43.3, and everything is in feet. So 43.3 feet is how long that cable would be, or that wire, or whatever you're using, to connect from here to here. All right, so we use law of cosines on that one just because of the information and the situation that we had to figure out another side of the triangle.